Okay, so today's lesson is going to be on vectors and specifically getting into vector addition. So first of all, let's go back over what a vector is. A vector on paper simply are simply arrows that show both the direction and magnitude. Now the direction is represented by the way the arrow points, and the magnitude is represented by the length of the arrow. Now, so examples of vectors that we've discussed so far are displacement, velocity, and acceleration. Now we also just started talking about force, so I'm going to actually add that in there as well, because a force can be represented by a velocity vector as well. So now we got the magnitude piece, which is just simply how long the arrow is, but now the direction. So obviously we can say right, left, up, down, but the question becomes what happens when the vector is going maybe at some angle. So how can we describe that angle? So I want to come up with a system that works for both saying something goes up to the right and up to the left and down to the left and down to the right. So that's when we're going to come in and use the compass and reference vector system. Both of them work off of the standard Cartesian coordinate system that you guys are familiar with the x and y. Now, for the compass system, we represent to the right as east, up as north, west, and south. And then for the reference vector system, we just arbitrarily pick the positive x direction as 0 degrees. And just like that, you guys have done this in math class, 90 degrees, 180 degrees, and 270 degrees. Now, if I wanted to draw both vector A and vector B, displacement vectors, this is 20 meters at 10 degrees south of the western direction. And when you draw that vector in, we know that it's going to be somewhere between here, but the big question is whether it's 10 degrees below the west or 10 degrees to the left of the south. And so here's what this means. When I read this as south of west, what that means is I'm moving to the south of the western direction. So basically what I want to do is I want to start in the western, on the western axis, and I'm going to move 10 degrees to the south of it. So my displacement vector would look something like that, and my 10 degrees would go right there. That is to the south of the western direction. I'm going to label that vector A. And just so we know that when we actually write our vectors down, we put a little hat on top of it, and all it is almost like an arrowhead, just without the second tip of it. And so there's my vector A. Now vector B is 34 meters at 40 degrees east of north. So if we know that once again it's going to be up here in quadrant 1, and it's to the east of the northern direction. So I start off going to the northern direction, and then I move to the east of it. So I'm going to have something that looks like that. And there's my 42 degrees. Now, if I want to use it in the reference vector system, okay, which we'll use a little bit, we're going to actually use the compass point system more so, and this is actually what will be on your Regents exam. So if I'm using the reference vector system, we'll just basically have a number that is from between 0 and 359 degrees. And we basically just start from 0 and we start counting up. So for vector A, I have 180 degrees, so from 0 to 180 plus 10. So I could just write it as 20 meters at 190 degrees. And then for vector B, all I'm doing is going from 0 to where the 42 is, so this is 90 minus 42, or 48 degrees. One thing that's interesting to point out, that you will not have a compass point system that's going to be greater than 90. And also, you can always switch the two directions around. So if I want to describe the same vector, like vector A right here, I could describe it as an 80 degrees, but instead of saying south of west, it could also be west of south. So either way, 80 or 10, I could use to describe that vector. All right, so then changing systems, how can we go from one to the other? So it says, what is the reference vector angle for a vector that points 50 degrees east of south? Okay, so the first thing you want to do is you want to sketch the picture of it, 50 degrees east of south. So we're going in the southern direction, and we're going to be moving to the east of it. So my 50 degrees comes somewhere down here. So there's my 50 degrees. It's 50 degrees to the east of south. So now what I want to do to get my reference vector, I take 0 plus 90 plus 180, well, plus another 90 plus another 90 plus 50. So I get 270 plus 50. I get 320 degrees. Now for the reference vector for the second example here, we have 20 degrees north of east. So here's my east, and I'm going to be moving away from it to the north, and so I just have a 20-degree angle down there. So that angle right there is 20 degrees. Now since the reference vector starts off in the eastern direction and counted up, this is also going to be 20 degrees. So what we also want to do is we want to be able to add and subtract vectors to produce what's referred to as a resultant. Just think of the resultant as the addition of two vectors. And we're going to represent that with the letter R. So it's going to be R vector. We can multiply and divide a vector or a scalar to produce a vector. Or, actually, let's get rid of this. Okay, so hopefully you have a protractor at home, and if not, then what you can do is you can Google search what a protractor, or just an image of a protractor, print it off, cut it out. What I'd like you to do is go through and measure these angles. Okay, so for A, B, and C, measure the angle between them, and we'll talk about it tomorrow of what you got versus what your classmates and myself got when we measured it. But then also go down here on the second example, and so it says add a vector such that the given angle between them angle given is between the given vector and your drawing. So what I want to do is I want to draw another vector in, and I'm going to start from the tail of each of these vectors. So I want to draw another vector such that the angle between them is 45, 125, 10, 300, and so on and so forth. Okay, so try out both of these, and we'll chat about them tomorrow. All right, thanks for listening. Have a great night. Bye-bye.